I just like to play with these. I was like going to grab things. It was really good.
Okay, so we are going to move on to the last section, and the last section takes a big turn for the worse. We're going to take all the same scenarios we looked at before. Vertex is on the circle, vertex is in the circle, vertex is at the center of the circle, vertex is outside the circle, and instead of talking about arcs and angles, we're going to talk about segment lengths. This is going to be fun. Okay. So here's the first one. Chord-Chord Theorem. You have two chords that intersect inside a circle. Now, obviously, if this point R is at the center of the circle, it's a moot point. Why would we not care if R was at the center of the circle?
It would be a diameter of the chords.
Yeah, and all four of those guys would be radii, and you're done. That's easy peasy, lemon squeezy. If that point is not at the center of the circle, it's just inside the circle, then we can use some of this information to figure out side lengths. There are four pieces of information we're looking for. The left chunk of one chord, the right chunk of the same chord, the left chunk of the other chord, and the right chunk of the second chord. You need 3 of the 4 pieces of information. In a lot of these slides, you can pretty much forget about the black writing. What color is that? Blue. The blue is what you're going to want to use. Left chunk versus right chunk equals left chunk versus right chunk. Left chunk versus right chunk equals left chunk versus right chunk. And again, notice I didn't use the word half because it's not split in half. Okay? Need another second? Or are we good?
Good.
We're good. Next scenario. Vertex is outside the circle. We have some new terminology here. We looked at tangent segments, which were tangent segments, or segments that were created when you had a point outside the circle and tangent lines coming to the circle. That distance between the point outside and the point of tangency were tangent segments. Now we have secant segments. Okay. Secant segment goes from the vertex all the way through the circle to the other vertex, or the other point, I should say. That whole thing is a secant segment. Okay, so again, it goes from outside the circle all the way through the circle to the other end. A lot of people have a tendency to stop here. Well, you don't. This stuff, that MO, is called an external secant segment. Whole thing is a secant segment. The stuff outside is the external secant segment. What about ON?
Chord.
You could call it an internal secant segment, also known as a chord, correct?
Chord.
Okay, again, for those of you that are visual learners. Secant segment, external secant segment, chord. Oh, and look, 4 chunks of information. That probably means we're going to get another theorem, right? Yeah. Mm-hmm. There we go. Same picture, different theorem. Outside times whole, meaning the external secant segment times the entire secant segment. It's not outside times inside. That never applies here. Outside times whole equals outside times whole.
Can I ask you a quick question?
Didn't you just?
Can I ask you another one? I mean, okay.
Now you're
I
up
have
to
a question.
Oh, okay.
They've
been gone for hours.
Yeah. Can we change this to be in Y? Like
You can do whatever you want. This is America. Right on. Like that. Good job. I wouldn't be surprised if Emily didn't see her like swear under her breath when she walked by. Did you, Nikki?
No.
Or did you and you just don't want to admit to it?
I didn't.
Wait, we're recording this, aren't we? Just editing. All right, let's find the cursor. Where's my cursor? There it is. Let's take a look at this little sketchpad guide, which we can't open, so we'll skip it. Okay, so we look, I still can't open that. Why isn't that open? All right, let's just keep clicking on it until it doesn't open.
Until it doesn't?
Until it does open.
Next. All right. Now, I tweaked one small thing here. Wait, before you write, listen, because you might not want to write anything down. All I did is I took that other secant segment and I slid that point over here until they met. And so the secant segment became a tangent segment. You with me? The reason I said you might not want to write anything down is because the theorem hasn't changed. Okay, this guy. Outside times whole equals, well, how much is the outside?
10.
How much is the whole?
Oh, 16.
10.
Oh.
Still 10.
Oh.
Okay.
No.
What?
Okay, look, let's go back over here. Outside, we'll deal with MC first. How big is the outside?
X.
X. How big is the whole?
6 plus X.
6 plus X or X plus 6. Everybody good on that? Because that's an important point before we move on.
Yeah.
Good. Okay. Now look at the other one. How long is the outside portion? 10. How long is the whole portion? 10. Because when we slide that point over and turn that secant segment into a tangent segment, the outside and the whole are both the same. So if you want to write this down, you can. I wouldn't. In fact, I wouldn't write anything because it's the same theorem. We just change the picture a little bit. Still outside times whole equals outside times whole. And the reason I suggest is you don't write anything down is because then you can just think about where's the vertex again. We're back to that question. Where's the vertex? It's outside. What's the theorem? Outside times whole equals outside times whole. So it still fits into that puzzle piece that we're looking for, and we don't have to create another theorem. While we're waiting, solve for X. Oh yeah, we got us a quadratic, right? Yeah, 2 answers, what's going to happen probably? One of them probably doesn't work. Is that factor?
No, you have to do,
Pythagorean theorem? Or not Pythagorean theorem. I teach math. What is that other thing called?
Quadratics.
Quadratic formula. So we gotta do quadratic. I don't want to do quadratic formula. Let's not do quadratic formula.
yeah, that's fine.
Don't tell anybody, okay?
Okay.
So we just leave it like that.
Well, no, you would. If this were a test or a quiz, you would do quadratic formula and then get an answer there. But I will tell you this: that when you do quadratic formula, you'll get 2 answers. One will be positive, one will be negative. One of them doesn't work. Which one do you throw out? The negative, because this x is a distance, and we can't have a negative distance. Okay, good. So we'll pretend we did do quadratic formula. Unless you want to practice some no, okay, let's not be silly. Let's just move on. You would get 7.44, by the way, if you had done it. Just saying. All right, now solve that one. Here we go. If you're not already doing this, in your head, you should be asking yourself one simple question first. What's the first question you would ask yourself? Where's the vertex? You've only heard me say it a billion times. It's outside the circle. Thank you, Emmett.
Good job, Emmett.
Thanks.
And then the second thing is knowing the formula or the rule. Outside times whole equals outside times whole. Write your equation, solve for x. Sometimes you'll get a quadratic, sometimes you won't. Be careful with parentheses. They can be your friend or your worst enemy. Shoulders tired? Mary, your shoulders tired?
I'm okay, thanks.
You sure?
Uh-huh.
Come shoulders be tired.
Whoa, I messed up.
Uh-oh.
See, that's what...
That hurt to admit, didn't it?
Yeah.
What'd you get? What'd you, 20 more? What'd you get? That's 172.
Oh, you're correct. Yeah, Molly, we did do it.
Uh-oh.
6 times 6.
You got 24? What'd you get? Jack, what'd you get? 18?
You can't have it.
Okay, so I got 10, I got 18, I got 24, I got...
28 2/3.
You got what?
28.
28.6667?
I got 28 2/3.
Maybe we need to take a look at this.
This is making me happy.
All right. Will, what's the setup here? Quiet, please. Go ahead, Will.
It's 6
Good start.
times 6 plus x equals 8 times 8 plus 18.
Oh, yeah.
Dang it.
Nice job, Will. So I'm guessing some of you did, you're okay over here, and then all of a sudden you went 8 times 18.
Yes.
Yeah, outside times whole.
Yeah.
36 is 6x is equal to 162. I was gonna get there eventually.
That was sassy.
6x equals 36. So I can do this. 20. Right, 28.67. You guys have no faith in my mathematical skills.
Okay, I put it now.
Okay? Solve for x. Just because you haven't heard it enough. Where's the vertex?
On the outside.
On the outside. On the outside. No, that's round the outside. Remember, wrong lyrics. Around the outside. Let's see if we can get a little less discrepancy in this one. Oh. You smell that? Smells like a quadratic. If it's not a quadratic that factors, this time,
Wait, what's the formula of that?
you know that song, whatever the song is.
X equals negative b plus or minus square root of b squared minus 4ac all over 2a.
Thank you, Emmett. Appreciate the help.
No.
I didn't hear you, I'm sorry.
Do we really have to do this?
So
You don't have to do anything, Paul, it's America.
Yes!
I'm not doing this. I don't formula.
Let's see. Ben, what's the equation?
Added 5 squared equals x times 4 plus x.
Doesn't factor.
Great.
Yay.
I'm doing quadratic right now.
Oh, we're doing
X equals negative b plus. Can you write it down?
Yes.
Are you sure? Negative minus the square root of b squared minus 4ac all over 2a.
Whoops, not 2a. He said 2a, I wrote 2a. It's just 2.
Ooh, I'm really bad at like doing the what steps you go in for solving it. Oh.
Is dead fish.
Oh my god.
Oh my god.
I probably did that.
Oh, wait.
Oh.
Isn't it?
No, not like, yeah.
What's 116 divided by 4? 29?
Yeah.
Okay, 2 square roots of 29 over 2. Running out of room, let's bring this up over here. So then I get 2 times negative 2 plus minus square root of 29. Whoopsh, whoopsh. Negative plus 2 plus or minus square root of 29. There's the algebraic answer, but of course, we're in geometry. One of those doesn't work. Which one?
The second one. The negative works. The positive works.
The addition one.
What's the
Addition
square root of
works.
29 approximately?
I don't really know.
Well, approximately.
29.
5.
Oh boy. 5 point something, so therefore the positive would make it right. So you would get rid of the negative answer because x represents a distance, so x would be equal to negative 2 plus the square root of 29,
3.3.
or approximately
3.39.
3 point.
3.39.
3.17.
3.3415.
It's Pi Day.
Oh, it is?
It actually is.
Yeah. Pretty sure. Yeah, it's Pi Day.
We should have. I forgot.
3.39.
Solve for x.
Oh my gosh. I didn't even finish that one.
Cross it out.
That's not a diameter.
Oh, it is, isn't
Does
it?
the size being equal to their diameter?
Guys, Chord-Chord Theorem. Just
They're not diameter.
Where's the vertex?
Inside.
Inside. What's the rule?
Left chunk times right chunk equals left chunk times right chunk.
Outstanding. Set it up, solve.
4 times.
Uh-oh.
Mr. Reed.
Quadratic.
Yeah, smells like a quadratic. Oh, gotta practice. They're gonna solve themselves.
Alright, Vanessa, we know your left hand is strong.
Oh my god, this one's actually back.
No.
Oh wait.
Does it? I don't know. I haven't solved it yet.
Guys, come on. It has to.
Yeah, it is.
It factors?
Yeah.
Oh, I'm losing my touch.
So,
Morgan, what equation did you set up here?
4 times 4 is equal to 2x times x plus 3.
Lovely. 2x squared plus 6x, so 2x squared plus 6x minus 16 equals settle. So 0 equals x squared plus 3x minus 8. Where'd the 2 go?
You factored it.
What?
But again, where did it go?
Yeah.
That's fine, but where did it go?
Okay.
Divide both sides by 2. 0 divided by 2 is 0. Disappears.
Wait, why did you do
I just.
No, it's not.
This doesn't factor.
Oh.
Liar, liar, pants on fire.
Dang it. Guys, we're not doing this.
Guys, can I confess something? I don't know.
Wait, Mr. Sticky, why did you get rid of the 2?
Because it will be
But in the answer, you're supposed to
Guys,
write it with
quadratic
a 2
every
on
time.
it.
No. No, 2 doesn't matter.
I was taught
She didn't teach us. She taught us the quadratic song.
Okay, I remember
That's the
you
only
got to
thing
say
I'll ever
segment
remember
for
extra from this model.
Yeah.
It's the quadratic scale.
She gave us like 2 extra.
Okay, it's not fun when you don't have that.
Can you stop shaking that?
Which one doesn't work?
Subtraction.
Be careful, are you sure?
Yeah.
Because notice there's not just a plain old X up there.
I can't trust Paul anymore.
Wow. You're out of the circle of trust, I guess, Paul.
Circle of trust.
Decimal equivalents?
1.70.
1.70 und
Negative 4.70.
How did you put this in your calculator?
I'm guessing the negative 4.70 isn't going to work.
Yeah, it does.
It might.
That's clever, Ben.
That was so stupid. And we're done.
Darn. Darn the I love the same random thing. Like I just said, 2 feet to the
Huh?
You go upload the homework.
I will.